All right, class, this is our second class. This is Wednesday, August 27th. I hope everybody understood the syllabus and don't really have too many questions. I try to put everything on there that might answer your questions, and so refer back to that before you actually come to me. That's one thing that I cannot stand, is if you come with a question to me but it's actually on the syllabus, that just really irks me. All right, let's get into it. This is research methods, and my whole goal in this semester is to make you guys a critical thinker, to be able to digest psychological literature and to be able to assess its validity. And of course, I got to start off with a quote from a philosopher, and this one is from Ludwig Wittgenstein. He's an analytical philosopher. It says, "Whereof one cannot speak, thereof one must be silent." And that's the gist of science in general. We think of scientists as the lab coat and mixing chemicals and stuff like that, and electricity's flying everywhere, and or the mad scientists in the movies and stuff like that. And really, science isn't really necessarily about that. Science is really about reality. We want to understand what is, and this is the list of outcomes right now, but science literally means, the original word in Latin means to know, and that's what we want as scientists. We don't necessarily, that's why we don't really need the lab coat necessarily. It's what gets us from point A to point B, and B is the knowledge that we want. So we're going to begin with chapter 1, since I have a quiz for you guys, and you guys probably are more concerned about that than anything else. I don't know why, because this course is a lot of fun for me. But let's start off with methods of acquiring knowledge. We think that we know a lot of things, and I don't want to be too philosophical, but what is knowledge? Well, it's understanding the real world. That's the whole thing about science. And the three things that, the different types of knowledge that I want you to start off with is intuition. This is when a person has knowledge of something but cannot explain how they attain this knowledge. Insofar as science is concerned, though, this is not reliable. We don't want to say, oh, we have an intuition about something. We want to break it down. We want to understand what happened. We want to understand the processes, and then we're going to take that and apply it someplace. Authority. And this is actually really important, since you're treating me as an authority. When we gain knowledge from a person that is an expert in a particular field, I'm not certain that I would consider myself an expert, but at least I am an authority figure in this classroom. So a great example of this, though, might be a doctor for medical advice, or a lawyer for legal advice. Those are experts in their given field, and you would turn to them for information. The idea is that they have knowledge that can be gained by a rigorous study and application of that knowledge. Rationalism. This is somewhat older. This is a pre-Enlightenment style of philosophy. We still use some types of rationalism today, but not as it historically was. This is the idea that we can gain knowledge by reasoning and logic apart from evidence and experience. And in your book, it talks about René Descartes, who 17th century philosopher, and he had the famous cogito ergo sum, which is just I think therefore I am. And he thought that you could break things down logically and gain knowledge from that. We as scientists definitely accept some of that, because that's what we do with mathematics, but we want all of that to also be based in evidence and experience, and which leads us into empiricism. Empiricism is, in this form of, we gain knowledge from experience, observation, and evidence. This is very much an Enlightenment philosophy. This is it started off with John Locke, and we think that we're a blank slate, that we just start off with our senses and we take in everything, and then we learn from there, and then just build upon that. David Hume took it forward, though, but he said it's the notion that we should never take anything on another's account. We should, until we ourselves have seen and experienced something. And so That's the idea behind science, is that we want to experiment, we want to be able to show what it is and be able to repeat it so that other people can take that and build upon and stand upon our shoulders. Science, just basic. The first thing that I want to hit is induction and deduction. These are different types of reasoning, and this actually comes from that rationalism style of philosophy. And I think the best way to describe it, though, is induction is going from the specific to the general, and deduction is from the general to the specific. So if you did, say, induction, we have a specific event, and we're going to go out from there to generalize to other specific points. That would be induction. Now the other side of that, the other flip side of the coin would be, we have all these events, and we're going to use that in deduction to go to the specific. That's probably the most basic and straightforward way to explain it. If I tried to do any more, I'd probably confuse myself and you. Hypothesis testing, and this is actually very important for us nowadays. When we take a prediction and apply it, then gather data from what our experiment or application's results were, thus testing in the name. Logical positivists in the early 20th century started this out and pushed this forward. The Vienna School is what your book talks about. One can actually, you can see where empiricism actually overlaps or I guess permeates hypothesis testing, and that's the idea that we have to have experience, or we have to have a actual observation of what's going on, and that's what the idea behind hypothesis testing. Now the other side of that, though, would be from Karl Popper, who was a philosopher of science, and your book talks about falsification. We want a claim to be able to be wrong. I mean, there's plenty of claims that can be made, plenty, but we want the ability to be wrong on that, and that, like, I can say that there's an invisible fairy that's swarming, or like flying around my head. Well, I can't prove that wrong or right. I mean, neither can you. So we want to make that claim, and we go back to Ludwig Wittgenstein. So I mean, Karl Popper wanted us to have a claim, and then if it's wrong, it's wrong. Well, if it's right, well, we have evidence. But that nowadays we have kind of a mixture of both falsification and hypothesis testing, and we want both of those to intertwine. And that's the idea behind it, having a null hypothesis, and you guys should have learned that when you were with instructor Huff. Naturalism. Naturalism is pretty simple. It's just that the idea that science has to show how well it works and how pragmatic it is, and how it should not be making claims of more of a philosophical bent. Naturalists want something to be directly applicable to what you're doing. I can't really explain it anymore. Okay. Now we're going to move on to the basic assumptions for scientific research, and you should be able to see how all of this is linked together with, say, empiricism, hypothesis testing, and falsification. The first one is uniformity or regularity in nature. We want to be able to take that observation, and then we also want to be able to apply it in other settings, because if it's right, it should serve as a foundation from which to build on. I've been saying foundation a lot. Reality in nature. What we're observing actually is occurring, and that's the idea that takes forward this regularity. Like, if I find I find something, and I say it's true, and it just keeps on repeating, and I definitely find it's true, everybody else should be able to observe it and say, yep, that's what's going on. Discoverability. That's more of a thought that all things that we observe can be explained or will eventually be explained through scientific inquiry. And this definitely goes along with that quote that I showed at the beginning. If we don't have a claim, or if we make a claim, then it should be falsifiable. We should be able to test it. It's real. It has regularity in nature. We shouldn't make that claim. So we should just say, well, it could be discoverable. We could discover it, or it has been discovered. Only through scientific inquiry or rigorous scientific inquiry can we really find it. Sometimes nature does not easily reveal itself to us, so we have to be able to take time. Okay. Characteristics of scientific research. We want control. In research, we want to eliminate anything that could cause what we are observing outside of what we are actually manipulating ourselves. So we need to control for all these outside phenomena. That's why we have laboratories. We want all of this, any outside influences to be controlled for and protected against so that we can show cause and effect. And if we can't get that, then all these outside hypotheses can come in and ruin our data, and we won't get grants later on, and I won't be able to teach you. Operationalism. In order for our research to be replicated or strengthened by our peers, we must rigidly define what we are studying. Operational definitions are used in science and psychology. In particular, we need to define our constructs or terms that define what we are studying and be incredibly precise. We do not want to be vague. We want to be able to be cut and dry. If I say that this construct is like this, these are the characteristics of that construct, and this is how I measured it, somebody else should be able to take all of those words, repeat it, and find the same thing. But if I'm vague, then they'll be like, oh, well, I didn't define it this way. I didn't understand it this way. And then, well, we have an argument and some interesting time at a conference. Replication. This is extremely important. This is the regularity in nature, in the reality in nature aspect of it. This is when research can be verified by another person or even by ourselves. This is why operationalism is so important, because if we are vague or misrepresent something, it can make it harder to replicate our findings. Like I said, if you're vague, it won't be able to be replicated just as we actually defined it earlier on. Okay. Role of the scientist in psychological research. And you'll notice that I did not put narcissism on there. Psychologists are usually thought of in particular circles as somewhat narcissistic, I think, maybe, but I didn't put that up there. Curiosity, though, is up there. Scientists should remain skeptical and always question even commonly held findings or beliefs. In fact, these are some of the most important things that we should question, is the most commonly held things. In fact, that's how you become famous in science, is to break down what's already been established. Patience, and this is incredibly important too. Science is incredibly powerful. I mean, it can do all sorts of things. We've sent a man to the moon, we have television, we have all these crazy things that we never would have thought of 200 years ago, and science has given us all. It can give us all this knowledge that we're gaining, and everything that I'm teaching to you. However, it can be hard for scientists to wait for findings, because these findings are so powerful, and they do impact those scientists and other people's lives so much. Scientists must not let themselves get carried away. We cannot just jump to conclusions or reveal our data too soon. Like I had said before, nature does not always reveal itself so easily, so we have to be patient and methodical in our approach. Objectivity. In a perfect world, we'd not let any outside beliefs or preconceived notions affect our research. But this is not completely possible. We don't live in a perfect world. I don't claim to be completely objective, and neither should you. But we must strive to be as objective as possible, regardless of the outcome, results, or experiment. If not, our own biases could affect it. Science does not care what my belief is or your belief is. It just is going to tell you what's there. If we don't like it, too bad. That's just how science works. Change, I think, is probably the most important thing. It's if we hold science explains the real world, and if evidence is shown that contradicts what we believe or what we think is established, then it is our beliefs that are wrong, not science, if the science is right, though. Science doesn't care, like I had said before, doesn't care if we don't like an outcome. That's completely irrelevant. One's feelings cannot change the truth. The objectives of psychological research. We want to be able to describe what's going on. This is just a straightforward of this caused that. We don't know necessarily how, we'll get to that later on, but we want the description. If I'm saying that I put a chair in the middle of the room and it's a different color and people sat down on it more because they like the color or something strange like that, I can say why that is, but I have to figure it out later on. That's where the explanation comes in. Why are they doing this? Why are they behaving this way? We have to be able to explain this, though, through science. Break down the process, and also so it can be repeated and applied later on. Science also needs prediction. We have if our description and explanation of phenomena are correct, then another person should be able to take what we have done and get the same result. And the next part is control or influence. And this is where we can take a prediction and if all relevant things are included or excluded, then we should be able to get the same outcome and be able to apply it in a much broader sense. An example of this, it could be therapies, and some of you are counseling students, not all of you. Some of you want to do, all the good work, which is science, like me, but we know that particular therapies are better for specific disorders. If we know this, then if we make sure that nothing else is influencing the behavior, we should be able to eliminate that disorder, provided that we did eliminate anything else that was influencing it, which is precisely what science is. And here in Avila, we have a counseling program that is based in evidence-based therapy and science. Not all counseling programs are based in that, but that's what we strive for here at Avila. That's going to wrap it up. We have a quiz that's due next week. We'll go back over this a little bit more on Friday, but we'll also be hitting Chapter 2. I left out some stuff in my slides, but I still want you to be able to read all of that. It could be on the test. It won't be on the quiz, though, but I will ask you questions about it, especially if I think you're not actually reading it. But that's going to be it. Thank you.
Thanks.